Hey everyone. So welcome to the first design system design video on this channel. And this is quite a kind of like an impromptu video because I'm preparing for an interview and I'm actually going through all the system design questions here so that I can understand how I will sorry, not understand. I can practice how I'll explain a question to the interviewer there. So we'll go through the rate limiter question in this video, and I'll try to explain for the best of my knowledge, from the best of my knowledge, as to how a rate limiter works. And in the future, if I find a better explanation, I'll definitely make another video. But this video would be a really a good example to anyone who is, preparing for system design interviews and doesn't know how to prepare, or basically wants to see how a noob performs, basically what's the level of a noob, and you can see if I clear an interview from this one, and then accordingly you can also get confidence ki, yes, if this guy can do it, then I can do it as well. So this is why I'm doing this. So what is a rate limiter? It's usually used to prevent DDoS attacks. Then we also use it to make sure that the resources aren't taking up too much of the computation power. Resources aren't taking too much computation from the infra. Okay. Then other is uh, we also are able to control the number of requests to to increase performance. So the you can like basically it will help you meet your SLAs if you have any for your product as per IP, so that you can distinguish multiple users. And then the reason why we take IP is because IP is more unique. You can't just have email addresses, or like we can have tokens which we can for in your system, but IP addresses are more like system tokens. So it's more like generic. It's more generic, right? IP. No matter what infra you work with, you'll always have some IP address for a device. So you can always use an existing key, identifier. So you can use IP. Then what we need to do is we need to inform the user when they are limited from the system. So for these but for these error codes, basically the error code we can return for to the user to let them know that they have been limited because of too many requests. We can return 429, which is too many requests. Now we can also make sure that we log the users and the number of requests they make, as this will help us identify any bad actors. So for example, if there is a region, or there is like a group of IPs which are trying to DDoS you, then we can definitely know that, yeah, these are the group of IPs, blacklist them, blacklist blacklist IP on the basis of analysis. And then this way we can always make sure that we are safe. Now there is a downside. No, not downside. Sorry, we have there's an answer for a technique that I'll tell you. There are multiple techniques we can use to how to say rate limit. First is token bucket system. We use a different color for this. Now, how does token bucket system work? Basically, you have like a set of tokens in a bucket, okay, and every request picks a token from the bucket, and since the bucket, bucket has a finite size, So bucket has a token container limit, like how many tokens it can contain. And if there are no tokens left, no tokens left in the bucket, we can't let the request pass through. So if I were to draw this out, how exactly does this work? Let me actually move this window here. Here we go. So let's say you have a bucket where is blue, 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 blue. I take blue. Brush. Let's say this is your bucket, okay? And it will contain multiple tokens. Token, 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 token. Okay. And every request which comes has to pick a token. So it will just pick this token and then process. This is done. Now, when new request comes, let's say it picks this token and then is processed. Similarly, I'll just strike everything. Once everything is done, okay. For example, let me actually remove everything. Let's say we don't have any tokens left, and a new request comes. It will check whether there are any tokens or not. Nope, there are no tokens. Then it will not be processed. So it will just be blocked here itself. There it is. So this way you can limit the number of requests that come. Now the next way, but yeah, let's talk about the downside as well to this one. So downside or disadvantage. So the disadvantages of this particular system is, let's say you scale up, okay, and you have way too many requests now. So you need to keep adjusting the bucket size because you have too many requests, right? After you scale up. So if you need to keep adjusting the bucket size, it's like really tedious as well. And if you keep adjusting the bucket size, you have to go through maintenance phases, Well, maintenance filling. Damn, I don't know maintenance filling. Maintenance phases, which means that you know you'll have downtime, more downtimes, which is not good. This will impact your SLA. As if you want to be more available for your customers, then you can't do that. You can't be down all the time. So that's one thing. Now there's another way, how to say this, technique, and that is fixed window system, or people also call this sliding window system. So what is sliding window? Like, it kind of gives you a how to say this idea, right? What I'm talking about. So what we do here is we only share what do we share? A small window or small time window with all the requests. So any request in this time window will be processed, and any request outside it will be not exactly cancel. It will be rejected. So you'll get I forgot the error code for returning rejected. I'll just display it after editing. Okay. Now this also has downsides. Wait, before I go to downsides, let me just explain how exactly will this work. So for example, you have a timeline where is my brush? Yeah, this is your timeline. This is your whole day. ठीक है 0000 then 23:55 59 23:59. There we go. So you will have small windows in which you will process the requests. For example, you will start at 4 a.m. then till 5 p.m. and then from 5:30 to 6:30, like that. So, or you will like, I mean, this is a very huge window. I'm giving you an example, but it could be a window of seconds or even minutes. Like, so that in within 1 minute you are processing all these requests, and then in the next minute you are processing all these requests. So what happens is, in this window, if some new request comes right after this window, it has to wait in a queue or something, and then when the next window opens, it will be processed in that window. So this queue system is optional. Like some people do keep it, some people don't. If this queue option is not there, it will be rejected. And so any request, let's say in the system where we don't have a queue, let's say a request came, but it is outside of the window, it will be rejected. So as you can see clearly, the downside is basically that if your window is too long, or if there are too many requests, disadvantage. Wait, disadvantages. So in scenarios, what will happen is, first of all, yeah, if there are requests which if there are requests which come outside the window, they will wait or get rejected. And what will happen is, you will have inconsistent data basically. So I am not sure what exactly is going on here, but yeah, this is pissing me off now. You will have inconsistency and inconsistency in your request graph. Basically what I'm trying to explain is, let's say, for example, this is your number of requests and this is the time. You'll always have like the request will go here, and then at a certain point of time it will stop, and then you'll have another spike. So these spikes won't be able to, you won't be able to handle these spikes, because there will be windows where you won't get any requests, and there will be windows where you get too many requests. So the your resources, they won't be utilized consistently. You'll have some kind of an inconsistency in your resource utilization. So this is not good. This is not good, as in this is the downside of it. But these are the two, how to say this, systems that I know: token bucket system, and the other is fixed window system. Now, if you have a small architecture, like you're creating a chat room for 4 or 5 people, then you can use this one, token bucket system, that only a certain number of requests can be made at a time. So only 5 people can chat at once, and then the other people have to wait, or they'll send a message, it will wait. Once a new token is created, it will be sent. And for systems, huge systems, like let's say for a Twitter system, Twitter is like huge, right? We have way too many users. We can have fixed window system. There we will basically have some kind of a short window of time, so that we can also manage these spikes. But you'll always have spikes. It will sometimes go like this, and then whoosh, it will ऊपर जाएगा. Then it will be normal, and so yeah, I always have spikes. I'm speaking this from experience. So yes, this is how a rate limiter works, and because there's a lot of stuff that we can do when it comes to system design. So let's just go to the system design board. I have a draw IO, using draw IO for that. There we go. Let's create a design board here. So what we'll start with, I'll just type here rate limiter. I wish they had a proper definition of, content, body and stuff. Okay. If it's too small, what I'll do is I'll zoom in. Yeah, there we go. I hope this is visible. I'll zoom in even more. So the requirements are, so what are the things that we need to take care of? First is that we'll always have to have a rule engine where we'll, get all the rules for the rate limiter. So in our system, we had two rules or two techniques: fixed window system and fixed, not fixed, token system. So this rule engine will tell us what kind of technique we're following. Then we'll have a cache, which will basically store the IPs which are whitelisted or blacklisted. Then we will have logging to analyze everything, and the rate limiter needs to be on the server side, because if you have it on the client side, anyone can bypass it from the client side. And yeah, that's it. That, I think this is a good requirement list. So I'll just keep it here. Actually, I'll move a bit. It's the left. There we go. So how will it work? Now, first we'll have a database, which is basically the rule engine. So rule engine, this will be used by the web server or the app server or whatever it is, service, which is used for the rule, which basically handles rate limiting. So this will be used by that. Then app service, we have, let's say, an actor here. We are sending a request. This will first go through a load balancer. So load balancer here, and this will be acted here, and then here. There we go. So this will go to the app service, and then this will basically check the rule engine. And before it checks the rule engine, it will also check cache for any whitelisted or blacklisted IPs, so that it can, before even executing a rule, if something is already whitelisted, doesn't matter. We don't need to worry about the rule. Just process it, and from here on, from app service, it will go to the actual application. Right. What I'll do is, instead of calling it an app service, I can call this app service. We'll call this the rate limiter. So that is what, yeah. And this will be the app service, the application for which we are limiting the rate. After this, it will go to the application. Yeah, that's it. If you have any questions, please let me know in the comments. And if I have done anything wrong, please also let me in the comments, so that I can, improve and stuff. And oh yeah, by the way, let's also add a a writing service for, let's say here to cache, so that if, let me actually delete this, or let's add it like this. Okay, there you go. So the rate limiter will write any whitelisted IPs in the cache, and it will also read any whitelisted and blacklisted IPs from the cache. So yeah, if I have done anything wrong, please let me know in the comments, and I'll also check this video again to see if I've done anything wrong. And I'll see you in the next one. Bye bye.